In the time it takes me to say this sentence, roughly 1 billion particles just passed through your skull and your brain didn't notice. These particles don't interact with light. They don't interact with atoms. They pass through lead, through planets, through you, as if nothing existed at all. And here's the unsettling part. This invisible substance makes up 85% of all the matter in the universe. We've mapped it. We've weighed it. We've watched it bend light across billions of light years. But we have never, not once, touched it. What exactly is dark matter, and why does it seem to exist in a universe parallel to our own? For most of the 20th century, we thought we understood galaxies. Stars orbit the center. The further out you go, the slower they move. Simple gravitational mechanics, just like planets around the sun. Then, in the 1970s, astronomer Vera Rubin measured something impossible. She pointed her telescope at the Andromeda Galaxy. She tracked how fast stars were moving at different distances from the center, and the numbers made no sense. Stars at the outer edges were moving just as fast as stars near the core. That shouldn't happen. At those speeds, the outer stars should fly off into space. The galaxy should tear itself apart. Imagine a merry-go-round where the kids at the edge are spinning as fast as the kids in the middle, but somehow none of them fall off. The only explanation: there had to be more mass, a lot more mass. Something we couldn't see was holding these galaxies together, but here's where it gets strange. When astronomers looked at galaxy after galaxy, they found the same pattern everywhere. The visible universe was just the tip of the iceberg. So how do you weigh something you can't see? You watch what it does to light. Einstein predicted that massive objects bend space-time. Light traveling past something heavy will curve. It's called gravitational lensing, and it works like a cosmic magnifying glass. When astronomers pointed the Hubble Space Telescope at massive galaxy clusters, they saw something remarkable. The light from more distant galaxies behind the cluster was being warped, stretched into arcs, sometimes duplicated into multiple images. By measuring exactly how much the light bent, scientists could calculate the total mass doing the bending. The visible matter, the stars, the gas, the dust, accounted for about 15% of the required mass. The rest was invisible. Wait, but here's the number that breaks most people's intuition. There's roughly 6 times more dark matter than regular matter in the universe. For every kilogram of atoms that make up your body, your planet, every star you've ever seen, there are 6 kilograms of something else. Something that doesn't emit light, doesn't absorb light, doesn't collide with atoms. It's there, but it exists in what feels like a shadow dimension, which leads to the part that most people never hear about. Dark matter isn't just around us. It's the scaffolding of the entire universe. Computer simulations reveal something stunning. When you model the distribution of dark matter across cosmic time, it forms a vast web, filaments stretching millions of light years, nodes where galaxies cluster, voids of almost nothing in between. Regular matter, the stuff that makes stars and planets and people, falls into this dark matter web like rain collecting in gutters. Without dark matter, galaxies wouldn't form. Stars wouldn't clump together. The Milky Way wouldn't exist. You wouldn't exist. The visible universe that we photograph, study, and call home is essentially riding along on an invisible framework we've never directly detected. Here's what keeps physicists awake at night. Every detection attempt has failed. We've built detectors a mile underground to block cosmic rays. We've cooled tanks of liquid xenon to near absolute zero. We've waited years for a single dark matter particle to bump into a single atom. Nothing. It's as if the universe is made mostly of a substance that refuses to acknowledge we're here. So the real question is, does this change what we think is possible? Right now, deep beneath mountains in Italy, South Dakota, and China, scientists are running the most sensitive experiments ever built. The Luxi PLIN detector in South Dakota uses 10 tons of ultra-pure liquid xenon. It's waiting for one particle of dark matter to knock into one xenon atom. That single collision would release a faint flash of light. Detectors are ready to catch it. Above ground, the Large Hadron Collider smashes particles together at nearly light speed, hoping to create dark matter in the debris. Satellites map the distribution of dark matter across the cosmos with increasing precision, and theorists are working overtime. Maybe dark matter isn't one particle but an entire dark sector, a hidden family of particles with their own forces, their own physics. We might be sharing the universe with a parallel world of matter that we'll never touch. The next decade could change everything, or it could deepen the mystery. So right now, as you watch this, billions of particles are passing through you. They pass through the Earth to reach you. They'll continue through the planet and out the other side, and you'll never feel them. The universe is built on something we cannot touch, cannot see, cannot hold. We only know it by the shadows it casts. We might be closer than ever to finally catching one of these ghosts, or we might discover they don't play by any rules we understand. Here's my question. Do you think we'll detect a dark matter particle in the next 20 years, or will it remain physics' greatest phantom? Drop your prediction below. Follow for more, we post every week.